Okay, here we have a ball with a potential energy of 100 joules, and we're going to drop that ball down to the ground. What's going to happen when it's just going to touch the ground? Well, potential energy is equal to mass times gravity times height. So if we get to a position where the height is 0, the potential energy will be equal to 0. What does that mean for kinetic energy? Well, if there's no air resistance, what happens to this 100 joules? It all turns into kinetic energy, in other words, the energy of motion. Now, most of you are probably okay with that part. The part that's a little tricky is finding the velocity. There's only one equation that involves velocity that we have at this point. K is equal to mv squared divided by 2. Let's go through and look at what we have. So we have the kinetic energy. We don't have the mass, we are looking for this velocity. So in other words, we're gonna have to go find that mass. How do we do that? Well, let's go back and look at this equation. So if we know P is equal to mgh, and the potential energy up here was 100, we don't know the mass, G was 9.8, and the height of this stick at the beginning was 1. The height we dropped it from at the beginning was 1. We can divide this out and find the mass. And we get a mass of 10.2 kilograms. Now that we know the mass, we can put it into K is equal to mv squared divided by 2. So K is down here, so now we're dealing with down here. So we have 100 equals, the mass isn't going to change, even though we calculated the mass when it was up here, mass doesn't change. So 10.2. We don't know the velocity, divided by 2. For those of you struggling with math a little bit, we're going to multiply this guy up. You could also have done 10.2 divided by 2. Either one's fine. But I'm just going to do it this way. We got 200 then is equal to 10.2 v squared. So 200 divided by 10.2 is 19.6 equals v squared. And to get that by itself, we're going to take the square root of the opposite side. Oops, 19.6, not 8. Okay. And our velocity is 4.4 meters per second.